kind of sent all the yeah, should be working. I sent all the corrections back. I think most of them were pretty, most of you did a good job. I think there were just a couple missing dimensions, that kind of stuff. Right? By missing dimensions, I don't mean that they're not visible or something, but they were just wrong. But they were like, 50 versus 20 and that kind of stuff. All right, if there aren't any questions, then I think we will jump into our topic for today, which is we're going to talk a little bit more about the different tools that we have for 2D sketches. So let's make another sketch. Again, it doesn't really matter where we put it. And so we've kind of talked a little bit about this first group here. Not so much about text and point, but they'll come up. And then we talked a little bit about trim and extend. And so today we're going to kind of finish out the rest more or less here. We're not going to talk about images and that kind of stuff. We're going to talk about modify section, the pattern section, and the constraint section. So maybe we'll start out again in the modify. We've done a couple of them already. So let's just draw ourselves a rectangle in here, no particular location. If we want to move it somewhere else, right, then we can just click on all four sides, right, because it's our select. Then we choose the base point wherever we want it to start, wherever we want to kind of grab it to move it, and then we can move it somewhere else. Pretty straightforward. We can also do a copy of it, right? So maybe we want to move it, but we also want to copy it. So again, we can select. We can either do them all separately, or we can drag a window around it, and then we hit the copy button. And again, I choose a base point, draw it there, and again, now we have two. Pretty straightforward. Copy is pretty much the same. The only difference really is that we can also, if you look here, it says copy to the clipboard, right? So you can copy from one IPT to another, right? So you could do the copy here and then go to a different file and paste it in there. That would be the big difference. The rest is all the same, right? Again, we have to select our geometry. We do a base point, doesn't have to be a corner, could be somewhere outside if I wanted to even, right? Doesn't have to be part of it. Usually it would be part of it because you want to maybe snap it to somebody, but to something, and then put it there. Now I can keep on making multiple of these, and then I say done. And there we are my copies, right? That's the copy command. Now, big quiz. What is the rotate command going to do? Right, these are fortunately these are more or less self-explanatory, right? So I grab my my geometry, I get again select the point, right? Maybe I'll do this corner point here. It's constrained because I had moved it around with all these others, so I say yes, I want to get rid of the constraints, and then I can make a move of it. Right, that's it. Similar as before. I could say I want to have I might want to make a copy, right? So let's say maybe I want to take just this line here, and I say I want to make a copy, and I need to select the center point. Let's do it around its edge here, right? So I would have a second line right there. Very straightforward. Done. Again, we've talked about trim and extend, right? The idea that I can cut my line into smaller pieces. I can take a line, extend it until it hits another boundary, and split was just taking them all apart. Then the next set here, scale, stretch, and offset. Scale and stretch, I don't usually use very often. Offset is actually quite useful. You're gonna get that figured out eventually, or? How many engineers does it take to unplug a mouse? Apparently several.
Next question, yeah.
All right, so scale is basically, again, as the name says, just kind of makes something bigger or smaller. We can again do one of our boxes here. We have to choose a point around which to scale. So again, let's do a corner point, and then I can, just by using my mouse, I can say I want to scale it, or I can say like, well, I want to scale it by a certain factor. Oops, wrong keyboard. Right, and then I have it bigger. Very straightforward. That was scale. Stretch is if I take just one piece of my geometry and move it around and keep everything else attached. Right, so if I do it here, then I can stretch the whole thing. That's all I'm gonna do. Let's do stretch. If I do these two, and then around the base point, right, then I can stretch this and make it look. The rest stays the same, but these get stretched out. Again, not the most exciting of all things, but the next one here is actually quite useful. That's called the offset command. So I can select a geometry, and then I can tell it how far I want to offset this geometry, right? So if I had a, like, drew kind of the center of something maybe, and I want to make it a certain thickness, right? I can say like, well, I want this tool to be 1 millimeter thick, and there it draws all those lines up. I don't have to do them separately and dimension them. Doesn't just do rectangles, it does all kinds of geometries, right? And so the cool thing is you can kind of see here that as it gets smaller and smaller, it actually figures out that it turns into a triangle and no longer a polygon, right? Of course, I can go inside, I can go outside, all kinds of things that we can do with these. So it's really quite helpful.
Professor, one question.
Yes.
So, well, in the past assignment, I run some problems. I don't know if you can hear what we talk.
Yeah.
For example, can we just select an entire figure without, well, with all the other figures inside our main figure created, move along, like without changing all the lines? So for example,
What do you mean?
do you remember when, for example, the second assignment, you have to draw, for example, the two like columns up?
Right.
For example, I run with some problems that, for example, one of my lines was not entirely the dimension that the assignment was asking. So I have to delete all the line. Well, I deleted the line and delete the other lines that were touching it because I couldn't like move it along.
Right, so most likely what happened, and we'll talk about this a little bit more later, is that if you do something like, oh, you had something like this, right? There. Right, and then as you're doing these things, that you will see that if I'm just kind of not connected to anything, then it's kind of, there's a whole bunch of little dashed lines.
Yes.
Right, once you go here, that line is no longer dashed, right? You can kind of see that connection. So it now thinks that you definitely want to have this at the same height. Right, and so it now kind of makes a connection between these 2 points, so that if you start playing around with other lines, it will, you won't be able to dimension it separately, because it really thinks that the height, the location of this line, the vertical location of this line and that line are supposed to stay the same.
For example, we have a circle inside the hole, well, a hole inside this figure. Is there a chance or I don't know, a movement in the program that lets all that figure, for example, in this axis move to the y-axis, for example? Like,
I'm not sure what
you.
Sure. That's what we just did, right? So if I want everything but the circle to move somewhere else, right, I could say move this, and that, and then say select a base point, say this one here, and I move it there.
And if we want to move also the circle with all the figure, we just select them.
Yeah, you can just do
With
you can just draw across.
oh,
And if you if you've done something that you didn't want, you can just click on it. And you can't actually. Is that
okay,
kind
yeah,
of?
no, that was my question.
Okay.
Thank you.
So what else can we do? Let's do, next we'll do these right here, the pattern commands. These can be very, very, very helpful, but also sometimes a little annoying. Basically what these pattern commands are, they take existing geometry and create a pattern out of it, right? So they either do a linear pattern, rectangular one, or a circular one, or just you can mirror stuff over. So we just look at, if we start with the rectangular one, right? Opens up a nice little new window here, and it already has the geometry selector highlighted, so we can just select our circle here, for instance. And then it asks for a direction. Now this direction has to be some kind of line that you see within your drawing. If you don't have a line that goes in the direction that you want to do, then you just have to put a little line in there. But if we want to, for instance, have the circle, like, a pattern in like the horizontal direction, right? Then I could just choose this one, and you can already see that it kind of says like, okay, here, this will be my second circle, right? So I can say, oh, maybe I want to have more than 2, maybe I want to have 5, and maybe I want to have them all closer together, let's say 5 millimeters apart, right? And so it does this pattern for me. I don't have to go and measure and put all those circles in there. If I want to have them go in the other direction, right? You see the place where I said this was kind of my direction to follow. There's a little arrow there now. If I want them to go in the other direction, I just hit the kind of this button right here, which changes the direction. I can also do a second direction, right? If I don't want to have a pattern that's just kind of a two-dimensional, but I want to have the whole thing filled out, right? Then I could do a second direction, and I can say maybe I want to have 3 in that direction, and I want the distance of 2. Right, and then say okay, and I have all these circles done out. Now the problem is that these are all linked together now. If you want to do anything separate with either of those, you have to kind of go through and delete constraints, because they're all, they all belong together at this point. These rectangular patterns don't have to be at right angles to each other, right? So I could say, if we go over here somewhere, let's do a slot maybe. All right, I say, do my rectangular pattern again, because this is a slot, right? It has multiple different parts to it, so make sure that we have them all. And I say maybe my first direction is just a regular. Here, let's do 4, and let's do 3. No, 3 is one close. 5. Right, but then I can say for my second direction, I could choose any of these directions that I have here. Right, and so it doesn't go straight down, it goes away at an angle, or maybe even if I want to have more of an angle, I could do that one right there. Right, so there's all these different ways that we can create these. Questions? Great. Then let's move over here where we have a little more space. And let's do a rectangle. So now we can also do circular patterns, right? So I can grab my box here and I can have it turn around a point, right? So just like before, we choose our geometry, and then we'd have to choose a point. Now I can't just use any point, I have to use a point that exists somewhere. So maybe what we'll do is we'll first, for this example, we'll just put the point somewhere over here. Right, just with the point command, it's just whatever there. Back to my circular one, grab my geometry, and say, this is the point I want to go around, and you can already see that it's putting these in. All right, so I can say maybe I want to have those, maybe I want to have or whatever, 8. Maybe I don't want to have those 8 stretched over the entire 360 degrees. Maybe I just want half a circle. Maybe I want that circle to go in the other direction. And okay. Right, so we have a circular pattern. Can save us a lot of time and effort. Now, if we go back into this entire sketch, right? So this would be the circular command. What else can we do? I said the mirror command is another one that we have. What are we gonna mirror? All this kind of stuff. Let's do that box. Right, so let's say I want to mirror this box. Oop, for some reason, I popped that all the way over here. All right, so I select my geometry, and now I need to select a line. Again, that can be any line that I have. Let's do this one. Oop. Not yet clicked on the mirror. This is my mirror line, and I do apply, and there my new part appears. Again, we have to be a little careful because now the new part is still linked to the old part. So if we wanted to do something with that new shape, we probably have to go in and delete all the constraints. But that's also very doable. Questions about these patterns? The good thing is their names are all pretty self-explanatory, so we don't have to worry about that too much. So then the last kind of grouping that we'll look at here is the constraint section. And we already used one of the constraints, right? We used the dimensions. We did a lot with that. So let's kind of go through some of them here. The first one is the coincident constraints, basically putting two things to fit together. All right, so maybe, let's give ourselves some space over here somewhere. Let's say we have some kind of a circle and we have some kind of a line, just to start out. And now I want to have the kind of this corner be with that together. So I could say, well, I do coincident, that point, and that point, and then they're together. All right. Now, if I start moving stuff around, then all of it is going to move around, right? So if I just do, okay, if I just grab this one and move it, right, then it will, everything else is going to move with it because they are now tied together. So that was the coincident one. That one's actually I use fairly frequently. Then we have one that's called a collinear constraint. So let's say we have a rectangle. Or maybe this is my rectangle, and then I have a line that goes like this, but I actually want to have that line to be in the same direction as the bottom edge here. Then I can say, well, I want to do my my collinear one, and then we can see these are now tied together. And if I move one of them, then the other one moves as well, right? So unfortunately, it will often do things that you're not expecting, right? My general expectation was that this whole box would move, but of course, the collinear constraint is between these two lines, and so if you move the line, well, you would have to have some other ones, right? You could say, well, actually, we can do this one too if we want to. No, actually, it's not going to work. I was going to say we can do the lock one, but you would have to. You can't do a collinear with these and those, right? If you do a collinear, then it would try to have this line the same kind of same line as those and those. That's not going to work. So you'd have to kind of play around with it a little bit to get the whole box to move. Next one here, let's do ourselves another circle. Right, this is the to get two circles together, so concentric circles. I can do one circle and another circle, and then it puts them that their centers are lined up. This is a fun one, but also potentially an annoying one, because basically you can say, whatever we have, this is the one that rules everything. Nothing else can change anymore, right? So if we if we choose that line there, for instance, to be a locked one, right, then I would no longer be able to move this line up and down. Because it is, I did the double lock, that's not what I wanted. Let's just lock one of these. Okay, already put that constraint, let's get that constraint right here, right, I can always delete constraints. Can't. Still in the constraint command, that's why. There we go, delete constraints. All right, so now I could move this without a problem, but if I go back and say these have to be, this one and this one have to be collinear, then now I can't move this up and down anymore because this line, I said, this has to be where it is, can't change it. And so if this and this is supposed to be collinear, then I can only move the line along here. Exactly, along that line, right? If I, had any of these other ones, then I can't change those anymore. Another one that we use a lot, even if we don't think about it, is the parallel one. Anytime you do a rectangle, you create parallel constraints. It's just that Inventor does it for you. Maybe we'll do a line here like that, and I say, well, I want this line and that line to be parallel, then it does that, right? So if I want to keep on moving this line around, then I can do that, but I wouldn't be able to turn it on its edge.
That would work for like the piece we did on the test. Like 50 steps. You have to move parallel lines.
Yes. But of course, in Inventor, you don't have to worry about any of that because once you've drawn it, you can have any perspective that you want. Right. So but we just, for instance, for that one, right, you could also use the what's probably easier in this case would be some kind of an extend command. Right, where you have a line, you draw the beginning of the line because you know where it is, and then say just go to where that cut is. There's many ways you can do it. Now we have parallel, we also have perpendicular. So we can say we have these two lines. We want them to be perpendicular to each other, and there you go. Right? Doesn't mean that they have to be connected. It just means that they're perpendicular to each other. All right, so if I try to move this one now, then I can only move it in that direction. If I say rotate, then I hope it's going to complain. See, it says can't do it unless you want to delete some constraints. And usually in this case, we would say like, yes, please go ahead and use the constraint because we probably use that constraint at some point to build something, but it's not really all that important. Two more here are the horizontal and the vertical constraints. And these can be a little tricky because the definition of horizontal and vertical really depends on what your coordinate system looks like. Right, so if I do something, if I say this one has to be horizontal, right, it turns out that it's shows up as vertical in my case, but it's because it was horizontal compared to the y-axis, and this is the y-axis. Right, so if I turn it like that, then yes, it is vertical. It is horizontal. Right? Same thing if I was to say I want to have a line to be horizontal. Popping stuff on the wrong screen, so I can't do that because that already has a constraint on it. But if I do another line here, right, if I say it to be vertical, it's going to stay vertical. And then let's do another circle. Now this one can be a lot of fun too, and that is the tangent one. So basically I choose a line and a circle, and it is going to move the circle or the lines to make sure that we have tangent where they are tangents, right? So I can use, for instance, this line and that circle, and now it moved it in a way that I was not expecting it to. It just moved it kind of on the extension of this. So often what we need to do is we need to move our objects a little closer together. So let's get rid of those constraints. And let's just grab the circle and put it up here somewhere. Right? If I do tangent between this one and that one, then moves it in there. Now, if I do another one, right, say this one and that one, then one or two things happens, right? Either it moves the line or it moves the circle. So maybe this is one of those examples where we can use the lock, right? So if I say like, well, I really don't want this line to move, I could use my lock and say like, well, I'm gonna lock this one. And now if I do this, my circle is gonna move. And it also took that other line with it, right? So sometimes Inventor can be a little annoying. Because it kind of says like, well, you put these together first, so I'm assuming it's important that they stick together, and it will do that. It is what it is. These other two I don't really use very much. This just takes, if you have two lines that are connected by an arc, then it kind of smooths it out. This one just, keeps symmetry in place. The circle one can, the equal one could be interesting, right? So if I have, for instance, two circles, and I say equal, right, then it's going to change one of them to make them the same size as the other. And if I go in now and do a dimension and put a 10 in there, right, then both are going to grow to 10. There is actually another way that we can do this. Like playing with, like keeping dimensions of two things the same. So if you do a dimension, right? Let's do a circle, for instance. Right? If I dimension this circle, you get this little box, right? And we've put in whatever number we wanted to, 10, for instance. But you can also see that it gives you a code, I guess you could say. So D22. If I go in here and say, let's go into here, we already have one, right? Instead of 10 millimeters, if I say D22, right, then it will keep this diameter the same as that diameter. So if I go in here and say I want to have this diameter to be 16, then the other one grows as well. And I said this circle is supposed to be the same as that circle, so both those grow, right? So if you have something where you're gonna potentially change diameters of circles or length scales or something, right, then sometimes that's a good way to go. All right, I think that was all kind of the little extra tools that we're gonna use. If you know all those tools are good, there's gonna be one more that's gonna pop up sooner or later once we do 3D, and that's the project geometry. What it basically does is that whenever you create a sketch, you're drawing on a single plane, right? Just like a piece of paper. In your sketch, you will be able to see all kinds of other lines from other sketches that you've done in the past, but they're not part of what you're doing. If you want them to be part of the sketch that you're using, so if you want an intersection or you want to kind of have a line start at another line or something like that, then you have to do this project geometry where basically you're taking that line or whatever it is, and you're moving it exactly to where you need it. But we'll see once we get. All right, finish, and we have this big crazy thing that we're not going to need anymore. Any questions about any of the tools that we did today? All right, then I think we'll go through some examples. And once we've gone through the examples, we'll let you work on your own stuff. Oops. Smaller. It looks what? It should not stay purple. Like the different colors on the lines basically mean how well constrained they are. So Inventor wants everything to be fully constrained, doesn't want any wiggle room left, right? If I just pick two random points and I draw out the line there, and I don't specifically say what the length is, I don't specifically say what the diameter is, what the angle is, then there's really not much that I know about that line. If I do any constraints, it's gonna move that line because it doesn't have any strong rules to that line. The more rules I learn to put to that line, the more constrained it's gonna be. And so the color scale is a little bit dependent on that, but it's not. I don't like to rely on that color scale because it's sometimes a little hard to see on different pieces of screens. All right, so let's do another sketch. This one now looks like millimeters to me, so let's do standard millimeters. And so now we're asked to draw this here. And they were nice enough to specifically point out that these kind of these kind of parallel lines here means axis of symmetry. We have two axes of symmetry. We have the one here, and we have the one there. So basically, we can get away with just drawing this 1/4 of our drawing, and then just do a mirror and then another mirror. So that's what we're going to do. In this case, I'm not exactly sure if it's the fastest way of doing it. I think it's probably going to be fastest would be just to draw one big rectangle, do another rectangle, do trims to the holes, and you're done, right? But in this case, let's practice the mirror command. So I'll do a sketch. And so basically, again, we're going to start here and we're going to draw our little kind of, oh, we're going to do a draw rectangle. We're going to start here, go there, and back. So that means we need to know the distance from here to there. This is one that's a little confusing because you have different length scales all over the place, but this says 50 from here to here. It says symmetric, so 50 from here to there. It says 20 from there to there, so we're left with 30. Can't put our line nice and straight. Put in 30. So that'd be 30. Now we're here. So it says right there that we have to go up 20. 20 up. Gives us here. Said this distance was 20. So let's do that. 20. And then it says from there to there is 50. And from here to here is 20. So that'd be 30. Oop, not at an angle. Straight. 30. And then let's see. Zoom out again a little bit. Now we want to go all the way back here. So that should be 50. And it should bring us back right to where we started. So it did. 50, and then we go down. Should be another 50, and it is. And with that, kind of our base shape is done. So now we can put the circles in. The circles are a diameter of 12. 12, and then we can dimension them to be in place. They're supposed to be 35 from the bottom here. 3, 5, and then 35 from that as well. Sorry?
No, 35 from me. 35.
Yes. And oops, this is the wrong one. 35, yeah, from this line right here. And then what else do we know where they are? No, 35 also in this direction. I wonder why I got them at exactly 40. So now I have my circle in the right spot. What else do I need to do before I can mirror? What's the opposite of fillet? What do we call the other direction? Like the fillet again is like on the inside. What do you call it when it's on the outside? What shape does it have? Yes, it's round. The outside is, when it's outside, it's called a round. That's just,
Well, which.
we do our tens, right? It says 8 corners, 1, 2, 3, 4, 5, 6, 7, 8. So we go into, it's the same command, it's just called differently. There's no round command, because it's the same, it does the same thing. Yes. Technically, it is a round, but in Inventor, it is a fillet. So remember to change the diameter, and then we do this and this. And we say, okay. Now, what I would suggest we do is 10. 10, yes. 8 times in 8 locations. 10. So now we can go ahead and mirror all this stuff. We can say mirror. And again, we have to decide what it is that we want to mirror. Now, we don't really want to mirror this line or that line, so it's not just select everything. We'll just go through. It's not that many pieces. That, and the circle. And then we need to choose the line. Doesn't matter which one you do first. Maybe we do this one first and say done. And it didn't do anything. Oh, because we should have hit apply and not done. Always hit that. Well, it's one of those things. Let's go through again and select all these. And then do the mirror line would be this one and do apply. And done. And there we have it. And we don't need this line anymore. We can get rid of it. And then we can do the same thing. Well, we can do mirror. 1, 2, 3, 4, 5, 6. 13, 14. And we have to choose our line, which is this one. To apply and done. We can get rid of that line, we don't need it anymore. And then all we're left with is hole in the center here, square hole. So we can do the 2-point center one, say that's the center, and we know in both directions it has to have be 20, right? Because it's 10 here, 10 there. That's only half of it, so it'll be 20 by 20. Right, remember that switching between these two is with a tab key, right? If I want to do one, then I hit the tab key and write the other. And there we go. This one? 20 by 20, right? It says here that from the center line is 10, and in the other direction it's also 10. It's symmetric, so it has to be 20 by 20. And I can use the one of the other rectangle commands that kind of chooses a center and then does the lengths. So with that, I can say I am done with my geometry. And it says a thickness of 16, so I'm going to hit extrude. It's popping in the wrong one. Choose my area here and say 16. And there we go. Looks more or less what we see there, I think. It's funny that it's the overall outline is a square, but it looks as if it's stretched to this direction because it's thinner for this part. Questions with this example? All right, then let's do another example.
How much of this?
I think it's at 16, but again, in this case, it doesn't really make a difference. All right, let's do this one again. Everything's in millimeters, so. Switch to a new one in millimeters. Now this one looks quite complex. That looks like a crazy shape. But it's actually not that bad, right? What did we learn? We learned the pattern command, right? The circular pattern. So basically all we have to do is we have to do one or maybe two of these, and then we'll just pattern them all around. We're done. A lot easier than it seems. Start our sketch. And so what I would suggest is we just start with one of these circles and then then go from there. Now we know that this circle right up top here, right, says it has a diameter of 160. This is the circle that they're all sitting on. So distance from the center to there has to be 80. So I could take a circle. Oop, I want to click it there. I want to do a circle, right? Then I can use my tabs to go through here. X is good. I want to have it on that straight line. And I know it has to be 80 up, so I can put 80 in there. And then those are all 20s. So I can put a 20. And that would be my first circle. Right? That's basically that circle right there. Now I could say like, well, I'll go ahead and pattern everything out. We can do that, but it's often better to wait until we finish.
How,
When you click to do a circle,
Yep.
right? Then I have the little kind of crosshairs, and I have the box that has the coordinates, right? If instead of just clicking and deciding this is where I want to have my circle, if I want to actually tell it exactly where it's supposed to be, I can just hit the tab key, and then this is highlighted, and then I just have to know where it is. You have to be a little careful with positive and negative, because again, like in this case, it fits. This is like, the positive, this is the all negative coordinate, but sometimes it's shifted and be different. And you just have to kind of like what I usually do, I just kind of put my mouse somewhere close to where I think it's supposed to be, and then I can see if it's positive, it's negative, which one's supposed to be 0, and which one's supposed to be a value.
value is 80.
80, right? Because the circle here has a diameter of 160.
And the diameter of these circular units
Is a 20, because it says 12, 20. Now, I've done this before, so I can tell you, once we start playing around with stuff, and we're going to use a lot of tangents and stuff, it's going to start trying to move stuff around. So I would recommend that either we dimension this to be perfectly in place, or we just say we want to lock this circle in place. We don't want to move it anywhere. So that's what we'll do. Now, to get these outside wavy parts, right? Basically what this is a whole bunch of circles that are just overlaid with each other and intersecting. So the first thing that we'll do is we'll draw another circle, and it says that kind of these outside circles, these are all radius 20. So I'm going to draw a circle. There, stuck somewhere. So I'll draw a circle that is a radius of 20, but I'm doing the diameter, so it has to be diameter of 40. So I have that circle right there. Now I know that it's going to intercept with some other circle, so I need to draw myself another circle. So what I'll do is I'm going to use my rotate command. Let's make sure we have copy linked in there. I'm going to say I want to rotate the circle, and I want to do the rotation based on this. So basically I'm trying to do this the second circle. And so I'm going to say I know it's 12 circles, 360 degrees, so I have a rotation of 30. Done. So this would be now that circle right there. So I'm going to use that circle and create another big circle. So that was a diameter of 40. Right, that, now these don't intersect, right, but we have now kind of this bump and that bump, so now we have to figure out how to get the bump that's in the middle here. And we know that that bump, it's a little hard to see here. Move this out of the way. The inside bumps are supposed to be R30. So what we'll do is we'll draw ourselves another circle. Somewhere up here, somewhere close to where we want to be. 1 second. And we'll say this is a diameter of 60. Yes,
I'm still in the road.
okay,
I get those two, and then it's asking like for the angle.
uh-huh. You can put 30, right? Because we have 30 degrees, right? We have 12 circles along a 360 degree circle. It also directly specifies down here that it's 12 times 30. It really doesn't need to. Then remember to hit the little copy button so that you get the second circle. Otherwise, you just move it. It's not that helpful.
I just moved it.
There you go. So now we can go in and we can use our tangent constraints. Right? We can say I want to have this circle and that circle tangent. And this is where you have to be really alert that nothing else moves around. Because as we saw before, right, if I do these constraints, there might be things that are more or less constrained than I think, so they're going to move around. But that's why we lock this first one in place at the beginning. So let's do another one. So this circle and that circle, and there exactly happened what we didn't want to happen. You see that? Let's get out of this command. Why did it allow that to happen when it was off? Right, this is where our circle was, where we had it. I said, and it moved it down. Right, so we have to somehow make sure that that doesn't happen. Thought my constraint there would work. Yeah.
Does the bigger circle has to be in
60, right? Because maybe it's hard. Maybe we can pop it out here. It's kind of hidden. Right? These are all R30s. That one, that one. The inside troughs are 30s. And so the diameter then is 60, because those are arcs 30. All right, so if we don't want that to happen, then maybe sometimes it's good to just throw a couple dimensions in there. So we say that is a dimension that we need, that we know. What else? Maybe we'll dimension it in this direction. And let's see if that's enough. So let's do the tangent again. Move the other circle. Sometimes I'm surprised the lock didn't work better. It's strange. Usually it looks better. Well, let's put that in there, and now we should have enough constraints to keep stuff in shape. Perfect. So now it moved just the outer circle. And then we can try the same for the inside. But maybe it's easier to see what we're doing if we start trimming some stuff away, right? So we trim that outside away, we can kind of see that we're getting that shape right there. And then we can do the second circle, right? The circle that goes there. Again, we'll draw a circle that has a diameter of 60. And now everything should be sufficiently constrained that we're not moving stuff around anymore. There and there. And trim that away. Right, so now we get one of these inside ones, says there R30 as well. You look kind of confused, concerned
Yes.
about what part?
No, I think I need more dimensions because,
Shifted stuff around?
yes.
Yes, it will do that. Yeah. I had hoped that the locking the circle in place, but I think it just locked the diameter in place, not the rest of the circle. So I'll have to look at that in a little more detail to figure out what the difference is. Now, we're almost there.
Um.
You can also
I
actually
wanted the bottom to just
trim those, sorry.
the same thing.
Yeah, I did exactly the same thing. Now we have these shapes more or less in place. So we could go ahead and just do a pattern, but then we'd have all these inside pieces still there that we don't want. So actually we want to add a little bit more, like a couple more pieces before we can do that. And so what we'll do is we'll do another rotate. We're gonna rotate this one and that one. Again, we'll do a copy. We'll choose our center point to rotate. And we'll say we want to do it another 30 degrees. All right, so now we have enough stuff that we can do the trims. We can trim here. And we can't quite trim there. Or do we need that circle in the end? Because this is gonna connect there. I don't think we do. Let's try this out. We can always go back. So let's get rid of this circle. And then let's say we want to do a circular pattern. So this one, that one, that one, that one. This. And we want to turn it around the center. And we need 12. And looks good. And there we have it. Right, we went from just a single one to the full one, right? Just go back. That's where we were, right? Right, so we're here where we have all these parts. And then we go to the circular pattern. Choose our geometry, it's already on, right? So this one. Gonna get some overlap. We don't have to choose all these. We choose all those. That's where we want to create the pattern. We have to define what the center of the circular pattern is. That's of course just, would be the center of our ring here. So there. Choose that right there. And then we want to have 12 of them instead of 6. We wanted to go the entire 360 degrees. So we can just say, okay. And then with that, we have our ring here. All these other like light blue lines are all just construction stuff. Now I could go through and do it all by hand, of course, but why if we don't have to, right? If Inventor can do the work for us, then that's exactly what it's for. Computer likes to do work, so let's give it some work.
When rotating,
I
do 30 degrees. And like before I apply, it looks good. When I press apply,
do. Maybe you clicked somewhere. Maybe it's because you're using a trackpad. Show me. I'm assuming there's some of what's happening is you're running into some issues with constraints. So instead of selecting all the stuff, let's see if this helps.
Right, so then I think you're trying to do it 60 or 30, but it's then snapping back. So we don't really need all this, right? All we need are basically those two. Um, I think there was probably something, some constraints. I don't know the little circle there that said it's half of the year or something. That don't even guess, but sometimes I have to be very honest with you, to make the stuff very right. What are you doing and why?
And. How do you, well,
Full circle again, right? All we have to do is we go in, we say we want to do a circular pattern.
the first thing,
Yes, because otherwise you have all those circles everywhere. That last one you can completely delete. We don't need it at all. Come back. Right, and then we're going to the circular pattern command. Like whenever you click on it, automatically has the geometry already turned on, right? So we just click on whatever it is that we want to integrate with the pattern. Basically, all we have. Can do some things we're actually going to do double, but that's okay. Then we choose the center of our geometry, right? Of our pattern. In this case, the center is just going to be the center of our overall circle here. So we do click on that one. And then all we have to do is adjust the number in our pattern to 12, right? Because we want to have 12 of those. And we say okay, and thankfully it shows up the way that we want to. It's not, sometimes doesn't work perfectly. All right, so that means all that's left is this kind of hole in the middle here. So we have two pieces. We basically have a slot and a circle. Start with the circle. It says has a diameter of 50, so that's not very good. That should be an arc of 25, but we'll let it slide. And then we have a slot. And we have a slot where we know the center, so we'll use the center one. We know this is supposed to be horizontal and goes out 40. And it has a radius of 10, so we have to put in 20 because it thinks about this other circle. Yes.
the slot, like the length, it refers to the center point of the.
Well, it depends, right? There's this slot right here, where this is the distance between the two centers.
No.
And then here,
The
it's
center point?
this is from the center to the center of the circle. So center of the slot to center of, like, you know, wherever the circle, like the half circles are.
Which is.
40, right there.
And then 10.
No, it has to be 20
20.
because, again, Inventor thinks that slots are circles. So it does diameters instead of that. It's a little confusing. And then all we have to do is trim out the inside stuff that we don't need. Yeah, no, this is just example stuff. The assignments are for today. And with that, we're done. So then we can check here. It says do the outside, so this area 6 and the other one 4. So we'll go extrude this part by 6. And then remember that, you know, that sketch doesn't disappear, it just gets hidden, so we can go back in, right click and bring the visibility back. And then we can extrude
Wait,
this part. 1 second. 2, 4. Yes.
how did you get the visibility?
Right. So you have something that says extruding 1,
Ah,
right? And then you click on the little plus sign. And then you see this little sketch pop up, and you right click on it and you save visibility. It shows up again. And then you can use it. Now it's visible, which we don't want to, so we can turn it back off, and there's our part.
The other part was.
Four.
Four.
Yes. Questions about this part? So the tricky part with these things, the real, I guess, the artistic part about it, right, is to look at this and kind of figure out how to construct it. Right, to figure out that, well, I'm gonna do a small circle and a big circle, and then have these other circle connect with it, and da. That's really the genius. Yes.
How did you know that?
How did I know that this is R60, R20?
That, like the one circle you did big over there was like, I don't remember, 60
There.
or something.
Because it points right here.
Ah, okay.
Yeah, it points on the somewhere that these are 60 as well. It doesn't really say that these are R20s. But they're on the same circle, so they have to be. There should be something that says that these are R20 as well, the folder at the bottom. Not fully
I have not
correct.
seen.
Yes, it's hidden. Just keep the magic alive. Questions about this one? We'll do one more and then I'll let you guys get on with your own. This one's a little easier. This is now going to be in inches, so let's do one in inches. So I'll go to English, standard inch. And so we have this pattern of circles and then kind of straight lines and some arcs here. So it should all be pretty straightforward. What this is supposed to be, I don't know. It's not quite the right shape for knuckles or something, for brass knuckles or something, but something like that. All right, so what we'll do is we'll just do one circle, we'll do a pattern, and then go from there. So our circles, these circles are all have a diameter of 1.
The smaller.
Like the inside circles, the holes of our piece, they're all 1s. This one, this one, this one, this one, right? It says 5 times 1, 1, 2, 3, 4, 5. Now we want to do a pattern, but we don't have anything going in that direction. So let's just draw ourselves a line. Doesn't have to have any specific length, just has to go in the right direction. And we want to do a rectangular pattern, and we have to choose our geometry. We did choose our direction. We have 1, 2, 3, 4. So it counts the one that you already have. It's one of them. It's 4, and the distance is supposed to be 1.5. Which one? What?
Was the one you did for the arrow?
But I just drew myself a line up here that's horizontal. And then you go in, you choose your geometry, and then you choose your direction. The geometry is like when you click into the command, the geometry one is already highlighted. So you're already choosing that. That's your circle. Would be your geometry. And then once you need to know in what direction your pattern is supposed to go, that's why you choose direction. Here, let's go back.
The one that says project.
Oh, the rectangular pattern.
Ah, okay.
Right, so if you do your rectangular geometry, the geometry button is already on, right? So that's whatever the pattern is supposed to include. In this case, a circle. And direction is just the line that we created for this very purpose. We said we want to have 4 of them, and we want it to be 1.5 inches apart. Say, okay. Zoom out, and there are 4 circles. Then we can do our other circle somewhere down here. Also a 1. And we know that the distance in that direction from this one, should draw somewhere else. This distance is supposed to be 2. Oh, wow. almost exactly 2. And then the distance is 1/2 inch from this one. 0.5. All right, it says here, distance is 0.5, that distance is 2. Yeah, right, it says right here, 2, between the centers. And that's what I have to. Half an inch from the second one.
In the middle.
Yeah, from the center of this one, right? It says right there, 1/2 inch. All right, so now it says that there's arcs with a radius of 1 in 2 places, but we have 3, but that's fine because the other one says that it's 1, 2, 5. So what we can do is we can do another set of circles. R1 means diameter of 2. There's 1. There's the other. Right, so these are kind of these curved shapes. So now we have to do the lines. The cool thing is that Inventor already likes to choose kind of the top of a circle, so that one's easy. Now the other one's going to be a little trickier, so let's draw the circle. This was a 1, 2, 5, so a diameter of 2.5. And now we have to have a line that's tangential here, and that's Inventor is not quite as good as choosing those lines. So we'll just draw a line that's somewhere in the right area, and we can use the tangent. Tangent there. And tangent there. Then trim off the ends. There and there. What else? We need to have this arc here, so that was an R4, so a diameter of 8. And we can also use the tangent command for that. Tangent that one. And that one, so it's not the right tangent. So let's move our circle a little bit. So the choice is a little easier to make for Inventor. There.
So basically it's drawing big circles.
Circles and straight lines. So all you're gonna do here, circles and straight lines in the end. And then what do we have to, what's left? Or does that look like our shape? So what do we have to do? Take all the stuff away. What command do we use to do that? Trim, right? So we go to trim, we can say like, well, this circle here we don't need. That part we don't need, that part we don't need. That one, that one, that one. That one, that one. And with that, we have only left what we need. So we can extrude, said 0.25. And we can check if it looks about right. Looks all right. So in the end, really quite straightforward. A lot more straightforward than the other, for sure. A big wheel with bubbles around in it. Took me a little bit to figure out how to do, to be quite honest. But it has a lot of that kind of things that we practice today, so I think it's a good example. Now, for you guys, we have a couple ones, I think it's 4. So we have this one right here. We have this one. They're all very straightforward. This one, of course, you're gonna use a pattern. This looks like a very complex thing, but I think you can do it. I don't remember the number. I think you can do it with 5, not 5 clicks, but 5 commands, something like that. It's a super fast thing, right? Because all this outside here, you don't have to do by yourself. You can use the polygon tool. You draw one circle and you have the pattern. And then all that's left is that hole. So it's 3 commands. And then lastly, this one, which clearly has an axis of symmetry. Now, the symmetry I would use for this part, I would use the symmetry. For the rest, it's really not all that helpful. Right, because these are all rectangles and circles anyway, so it doesn't make a whole lot of sense to do a quarter circle and then mirror it. You can just do a half circle. It's not more. All right, with that, we can at least get started. And we'll go from there. That's